Okay, this lesson called Quadratic Systems is the final lesson that we'll have before our test on this part of the unit. So we are going to finish up with quadratic systems, and we are going to solve and graph systems of linear and quadratic equations and solve and graph quadratic inequalities. But to refresh your memory, what is a system? A system is two or more equations with two or more variables. Okay, what is a quadratic system? Okay, most of what we dealt with before have been linear. It's a system that includes a quadratic equation. Now, what is a quadratic equation? A quadratic equation in standard form, we've seen it, y equals ax squared plus bx plus c. We have also seen it in vertex form where it's y equals a times x minus h squared plus k. So we've had two different forms. What does it mean to solve a system? That means to find the point or points of intersection. Now, what's important about that is remembering that when you write that point, it will always be in an ordered pair, x and y. So that's going to be the answer to our problems when we work them. All right, so to refresh your memory, as you can see from our pictures, and I'm sure that you remember otherwise, a quadratic equation, the graph of it, looks like a parabola, and a linear equation is a line when we graph it. So when we graph both of them together, we can either have two solutions, one solution, or no solution. And as we pointed out, we find that when we're looking for the points of intersection. So if this has 2 points of intersection, then we know that we're going to have two solutions. And if we have 1 point of intersection, then we have one solution. And I think y'all are very well and know that if they do not intersect at all, then we have 0 solutions. Or no solutions is what we usually say. Okay, so let's look at our first problem. We want to find the solution to this system. You're being given a graph, so we are going to solve it by graphing. And so to start off with, we will look at this first one. And I'm hoping that y'all recognize that as a PST. Okay, we know it's quadratic because it has the squared on the x. And so I'm hoping that you recognize and remember that factoring is y equals x plus 3 quantity squared. And when it looks like that, it means that my vertex is hk, and we remember we always take the opposite of what we see on the inside. So my vertex is negative 3, 0. Okay, and a in this case is equal to 1, and the key points that we've always used to graph would be 1, 1, 2, 4, and 3, 9. And this flashing is bothering me. I don't know why it's flashing. Okay, so let's go plot that. So that means I'm going to have negative 3, 0. And remember those key points are over and up from our vertex. So we would go over 1, up 1 in both directions. And then back to my vertex, over 2, up 1, 2, 3, 4 in both directions. Back to my vertex, over 3, up 9. And that's actually off my graph. But one of the things that I want to point out to you is remember that it would cross at 9, which is my y-intercept. Remember we've talked about 0c being the y-intercept. So that's a great way to know that you're doing the problem correctly. Alright, and now I'm going to do my best imitation of trying to draw a nice parabola, which is not good on this. Yeah, I missed that point, but y'all got the idea. Okay, so the next one, so there's my parabola. Now I'm going to go graph my line. And that, of course, is that thing we're familiar with, y equals mx plus b. And we always start at b, which is 0, 3. 1, 2, 3, that's that point right there. And then I have a slope of 1. So that means, and remember, I always like to actually draw it. So I remember, okay, it's positive slope. I got to make sure my line looks like that. So I'm going to go down 1 over 1, down 1 over 1. There's a point. Down 1 over 1. There's another point. Down 1 over 1. So you can see what my line is doing, okay, as I plot it. And now I'm going to go use a nice little tool that I have, graphing tool. You will use your nice straight edge and connect them. So it's going to look like this. Alright, so pretty good. Now those 2 points that we found, what are those 2 points? Okay, this first one is at negative 3, 0. And this other one is at negative 2, 1. Okay, and I'm sure y'all know that our graphing is not as accurate as technology, graphing calculator, or a computer. So when you do it by graphing by hand, it is very important that you check your problem. Okay, so when we check it, okay, I hope y'all remember, you check it, we got to put each of these into both equations. So to do that first one, I'm going to plug in for y and x. So y for this first point, y is 0, um, equals x squared plus 6 times x plus 9. And what am I going to put in for my x value? Of course, is my negative 3. So I put in negative 3 and negative 3. And you put that whole thing in your calculator. That, of course, is 9 minus 18 plus 9. And that checks, and that gives us, that one works. So now let's go try it for the line. So we would put in 0 into the line equals x plus 3. And again, I'm putting in negative 3 for my x, so that's my x and that's my y. And negative 3 plus 3 equals 0, so we're good. So we know this point checked out. Now we need to go check out the other point. So I'm going to go put in, it's y again. Oh wait, y is not 0 here. Y is equal to 1. And when I'm plugging it in, I'm plugging it into the parabola. So that means it's going to be, again, something squared plus 6 times x plus 9. And the x value that goes with 1 is negative 2. So that's what I'm plugging in this time. Negative 2 squared is 4, minus 12 is negative 8, plus 9 is 1, and 1 equals 1. So we're good. And then to go plug it into the line, 1 equals x plus 3. And again, my x is negative 2 this time. Negative 2 plus 3 is 1. So we're good. So we know that these 2 points are the solution to our system. Okay, so on the next side, we are actually not going to do it by graphing. This time we're going to do it by algebra. What's the solution to the system? Okay, you can use substitution or elimination whenever you're solving things algebraically, but we're going to use substitution. That's probably going to be your method of choice because you don't have to think much. If this is y and that's y, then what you're going to do is just go set these two things equal to each other. So however you wish to think about it, whether you're going to think about putting this there or this one there, the whole point is if they both equal y, they both have to equal each other. So I'm going to go put in x plus 5 equals negative x squared minus 3x plus 10. It is a quadratic equation, y'all, and to solve a quadratic equation, the main thing that we do is set it equal to 0. So we're going to get everything all on one side. And I want a positive x, so I'm going to move everything over to the left side. So when I add x squared, I have positive x squared. When I add 3x, 3x plus x is 4x. And I'm going to subtract 10, and 5 minus 10 is minus 5. Okay? Now this next step, do what you have to. It is going to factor, and it factors to x plus 5 and x minus 1, okay? If you still need help factoring, come see me, but I don't want to spend the time on this going over it again, okay? So we factor it, And then we set each factor equal to 0. X plus 5 equals 0. X minus 1 equals 0. And then, of course, I subtract 5, so I get x equals negative 5 here, and x equals, I add to move it to the other side, so it equals positive 1. Now, keep in mind, we're not done because we talked about this has an x and a y, so we're looking for a point, so we have to find the corresponding y value that goes with each of these x's. And you can plug it into either one, but I would take the simpler one, which to me is this line. So I'm going to say, well, y equals whatever I have for x plus 5. And what is my x value? It's negative 5. So I'm going to find out that negative 5 plus 5 equals 0. And over here, y equals, again, x plus 5. And this time, the x value that I got was 1, so the corresponding y value is 6. So when you write your answer, this negative 5 goes with that 0, and this 1 goes with 6. So my answer is going to be negative 5, 0, and 1, 6. Now, you have your graphing calculators, y'all. You can graph it and check it. You all know how to find the solution to them by doing that. Okay? All right, let's go do some more. Two more examples of this. What is the solution to each of these? Now, I hope you realize too, it's always good to talk about. This was a quadratic, so it is a parabola. This is linear because it doesn't have an exponent, so it is a line. If you look at these two, they are both quadratic. So we have two quadratics being on the same thing, and we're trying to find out where they intersect. So let's go with the first one. Again, set them equal. They both equal y. Just go ahead and set them equal to each other. So I'm going to have negative x squared plus 5 equals x squared minus 4x plus 5. Okay, so when you look at that, you need to, again, set everything equal to 0. So I'm going to take these, I'm going to take them over here because I want a positive x squared. So 0 is going to be on that side. I'm going to add x squared. So x squared plus x squared is 2x squared. And then I'm going to, oh wait, I have minus 4x, which is nothing over there, so that's minus 4x. And then subtract 5, 5 minus 5 is 0, so those go away, and that's all I'm left with. Let me write that in there. I probably should write that because that may be a little more challenging. So what we did is we added x squared to both sides, and then we subtracted 5, which is why they canceled out on both sides there. Okay, so again, we're solving the quadratic. It's set equal to 0. Always want to try factoring first, and this one has a GCF of 2x, leaving me with x minus 2. And just like we did before, we're going to set each factor equal to 0. 2x equals 0, x minus 2 equals 0. Divide both sides by 2, x equals 0. Add 2, x equals 2. Now I have to go find the corresponding y value. So I go back, and it doesn't matter which one you use, you just, whichever one's easier for you. So I'm going to use the shorter one, negative whatever x is squared plus 5. So that's what I'm going to do on both of these. Y equals negative x squared plus 5. So what do I have in this problem? X is 0, so I'm going to plug it in here, and over here I'm plugging in 2. Now, negative 0 squared plus 5, of course, is 5. And here I have 2 squared. See, that negative's on the outside, so I square it first, giving me 4. Negative 4 plus 5 is 1. So again, here's my ordered pair. That x goes with that y, that x goes with that y. So that gives me, if x is 0, y is 5, and if x is 2, then y is 1. And that is the solution to that system. Okay, this one, same thing. We are going to Set those two things equal to each other because they both equal y, so that gives me negative x squared minus 5 equals x squared minus 4x plus 5. Similar to that first one we did. Okay, we're going to do the same thing, and we're going to, excuse me, subtract. No, actually, I'm going to add the x squared to both sides, so add x squared. This time I'm going to add 5 because, again, I want my x squared to be positive, so I'm moving it all to the right side of the equation. So 0 equals 2x squared minus 4x plus 10. Okay, first thing we always do is factor, and I hope y'all all notice that there is a common GCF, and you can factor out that GCF, y'all, but now we have an equation, and as long as we do it to everything on both sides of the equation, I can divide. So that makes my numbers even smaller. That's leaving me with 0 equals x squared minus 2x plus 5. So factor it. Do the factors of 5 that add to give me 2? No, they're not. Okay, so you can put it in the quadratic formula. I'm actually going to complete the square, y'all, because I have an even value, an even number here, and that's 1. So I'm going to take my 5 to the other side, which is going to be negative 5 plus blank equals x squared minus 2x plus blank. That's the process that we use to complete the square. And to complete it, we take 1/2 of that number, ignoring the sign, because we'll square it, it'll be positive. 1/2 that number squared in both my blanks. Negative 5 plus 1 is negative 4. And this, of course, factors to x minus 1 squared. So that was completing the square. And then I'm going to take the square root of both sides. Square root of negative 4, we just learned in the previous lesson, that is plus or minus 2i equals x minus 1. Okay? But hey, y'all, it equals 2i. And if you get a complex number when you're solving this, that is enough to tell you that there is no real solution because these solutions are complex. And when you get complex solutions on this kind of problem, that means that we're solving, there is no solution. And I know that you remember that means that these graphs, if we were to graph them, do not intersect. So you're getting the algebra that's going behind the picture and understanding. Okay, so remember, inequalities means there will always be shading involved. Okay, so this time to solve our inequalities, interesting. To solve our inequalities, we got to graph both of them because that's the only way we have to solve inequalities. The solution is always some shaded region. Okay, so the first one, let's go do, I'm going to graph this parabola right here. Now, to graph it, to graph a parabola, if it's not in vertex form, you got to put it in vertex form. We're going to find the vertex somehow. So I'm going to go put that in vertex form. And we have, when we did this in class, we had y equals, we didn't have a negative on it, so we actually need to factor that negative out, leaving me with x squared. If it's minus 4x and I take out a negative, it's now going to be plus 4x. I'm adding something to complete the square, and then we just moved that 3 over. And normally we said, okay, if it's plus here, it's going to be minus there when I'm on the same side of the equation. But remember that plus is inside parentheses that everything has been multiplied by negative. So actually, it's going to be plus this time. So what number do I put in there to complete the square? I take 1/2 of b and square it. And then I multiply it out right here. So if you look at this, y'all, this is 4, but it's inside parentheses in which everything is negative. So I really put in a negative 4 right here, which is why I have a positive 4 here. Okay, so now we factor it, and that gives us y equals negative x plus 2 quantity squared plus 7. Okay, so That hopefully is enough to remind you that my vertex is at negative 2, 7. Okay, that's my H, that's my K. This tells me that it's going to open down because it got flipped over the x-axis. And the key points that we used to graph were 1, 1, 2, 4, 3, 9. So I'm going to go do that. So I'm going to go graph negative 2, positive 7. And then from that point, I know I'm going down. Okay, so when I go over, I'm going to go down 1. There's several ways you can go about doing that. If I go over 2, I'm going down 1, 2, 3, 4. I'm at the y-axis, y'all. So I check that point. That point happens to be 0, 3, which is exactly what I have right here because that's my y-intercept. So that's just a nice checkpoint to know you're graphing correctly. And here's the other point. And then I go back, and if I go over 1, 2, 3, I'm going to go down 9, which is going to be right here and here. Okay, now to graph that, remember we also have to think about whether or not our line is going to be solid or dotted. And y'all are really good, so you know that if it's equal to, it's going to be solid. So I'm going to try to graph my parabola. Yeah, like that. And then I have to think about the shading. And so y is less than or equal to. So we've talked about going to that y-intercept and shading below it. So that means I would be graphing inside my parabola in this case. Okay? So now let's go find out where that line goes, and then we got to find where the two intersect. So my line is, I'm thinking about to graph it. Oh, it's not a line, it's another parabola, y'all. Silly me. Y equals x squared plus 3. Okay, hopefully you can see that if it's in vertex form, the number with x is 0, so that's 0, 3 is my vertex. It's going to open up, and my key points are going to be the same that I have here. So I'm going to go to 0, 3, put that point, and then I'm going to go over 1, up 1 in both directions. Back to my vertex, over 2, up 4. And then I look here, and there's no equal sign, so that reminds me that this is actually going to be dotted. So I'm going to dot it. Sometimes it's a little bit easier to make it look like a parabola. And then this says y is greater than, so I go to my y-intercept and I go greater than it on my y-axis, which means I'm shading this way. So my points of intersection, I hope you can see, are those that are above this parabola, the green one, but below the purple one. So it's this piece right there. So that is the solution. I'm looking for that shaded region. Okay? Now, there's one other thing that I want to tell you. If you don't feel comfortable putting it in vertex form, okay? Another method that you can use to find the vertex of a parabola. All right? Another method for the vertex. So think about which one, and if you have any questions, come see me on this. But when you have it in this form, y equals negative x squared minus 4x plus 3. We've talked about that that's standard form. So this is a is negative 1, b is negative 4, and c is 3. And you can find the vertex by finding negative b over 2a. And when you find negative b over 2, that's negative, and then I have a 2. My b is negative 4. I like to use parentheses around it. My a is negative 1. So I simplify that, and when you simplify it, it becomes negative 2. And then you're going to take that negative 2, and you're going to go plug it back in to the equation to find out what the corresponding y value is. So when I do that, it's going to be y equals negative something squared minus 4 times something plus 3. And I'm looking for the y value that goes with this x. So this is negative 2. And when you put that in and you simplify it, you find out that y equals 7. So this is another way that you can see our vertex is negative 2, 7. So that matches with what we got here. Figure out whichever way you like better and stick with it, okay? Or it's also a great checking point to make sure you're doing things correctly. Okay, one last thing that I want to talk to you about, another problem, and that is we haven't done a lot of graphing where a was not equal to 1. So I want to make sure that you know how to do that. So let's go do this problem. So we have y equals 2x squared minus 3x minus 1. All right, and so when I graph that, remember a is equal to 2, b is equal to negative 3, c is equal to negative 1. I'm not putting it in vertex form, y'all, because when I take out that 2, then I'm dealing with a fraction. So I think it's going to be easier to say, I'm going to go do negative b over 2a. So negative b over 2a gives me b is negative 3, and 2 times a is 2. So this simplifies to 3 over 4. And then remember to find that corresponding value, I got to go plug it in. So y equals 2 times something squared minus 3 times something minus 1. And I'm going to go plug in what that x value is that I want to know the corresponding y value. So when you put that in and you simplify it, you get the number negative 17 over 8. And if you need to put that, that's negative 2 and 1/8. So when you plot this, okay, to actually plot that point, I'm going to go over 3/4 and down just over 2. So I'm just going to kind of get close to the number. Almost to 1 and just after negative 2. We have the same set of, oh no, this is what we need to talk to. Okay, so my key points are 1, 1, 2, 4, and 3, 9. But notice this time a is equal to 2. And when a is equal to 2, it changes this number. And we've talked about this, but not a lot, so that's why I wanted to do an example for you. So a is affecting the output, and we've talked about how that stretches our parabola, makes it go up faster, or makes a line steeper when we talked about it. So my x values don't change, but each y value is getting multiplied by 2. 1 times 2, 4 times 2, and 9 times 2. So now when I graph it, so I have this point, and if I go over 1, and it's all in relation to this box, y'all. So when I go over 1, I'm going to go up 2, and that's going to put me right there. And if I go over 1 this way, and I go up 2, so I'm supposed to be right up next to that line. Go back to my vertex, and if I go over 2, then I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm in this box. I didn't want to do that. Go away. I'm in this box, but I'm right up next to that line, kind of in the corner. Okay, go over here. 1, 2, and then up it's going to be on that same level. And I'm in, so notice everywhere I'm kind of in the same place in the boxes. Okay, and now I'm going to do my best to connect those. Yeah, I didn't do very good, but y'all got, yeah. Supposed to be curved. It's a little hard to graph on these things. Okay, so there's that. Now let's go graph the line y equals x minus 3. So I have 0, negative 3, and a slope of 1. So I graph 0, negative 3. That's right here. And I have a slope of 1, so I'm going up 1 over 1. So it looks like I might intersect in that point. Up 1 over 1. Okay, if I continue, I'm just making sure that I'm not going to touch that line, or excuse me, touch the parabola anywhere else. So now I'm going to go graph my line. Lots of trouble to get those colors. And it's looking something like this. Okay, I could probably straighten that out some. That goes through there. All right, so as I said, when we graph that, I'll highlight, it really looks like the point is right here. And that point is Looks like it's 1, negative 2. Okay, but so again, we're graphing it behind. I mean by hand. I wanted to show you what to do when a was not equal to 1. So I'm going to check this. I know it's on my line, y'all, because I started here and I went up. So I know that I have that point on that line. So I really just need to check it in here. So if I check it, does negative 2 equal 2 times 1 squared minus 3 times 1 minus 1? And if you check that, you'd find out it does. And that means that the answer to our problem is 1, negative 2. And what I also did, just to show you, because so you can get a better picture of it, but if you checked it on Desmos or you checked it on your graphing calculator, okay, then your graph would come up and you would look like this. And that was our vertex. Remember, it was 3/4 and negative 17/8, and that's the decimal representation. So there's the vertex, and if you blow it up, then you will see that it's actually just tangent to that line. You get closer and closer and you'll find out, but this is an example of just one solution. So I wanted you to see that a little better than my hand graphing, but again, another way to check it, and I wanted to make sure you know how to handle it when a was not equal to 2. So, hope that helps. If you have any questions, please come see me. You know where to find me.